Okay, just some background. So as you can guess, I'm not Finnish, even though I come from Finland. I hold my permanent resident in Finland, so I moved there around 25 years. I'm originally from Spain, so I really appreciate the organizer to prepare this weather for me, so I feel like at home, really nice. First, I'm not important, you can Google me based on the surname, but I would like to basically introduce briefly CUMURORE. The background is that when I moved to Finland, first I moved there because I wanted to do my PhD in the late 90s. In Spain it was really hard, no funding. Then when I ended up, it was very harsh weather, that's the first thing. But then the good thing is that I found Nokia. So then I started working at Nokia simultaneously while doing my PhD. So at that point then it was great because I had the opportunity to see all the history from inside the company, ups and downs. So you might know Nokia with the phones and now with the networks. And then later I decided to quit Nokia and then founded CUMURORE with the idea to build based on all the industrial experience, build these private networks. And when I came here with our partners, NGN, with Sven and his colleagues, I was really glad to see that they were able to build up the first private network in Kosovo. And most important, they were able to do the first voice over IP or voice over LTE. Why is that? Because in the late 90s, I was one of the few people that was designing the IMS. So the IMS that has been used for voice over LTE and now voice over 5G, I was with a group of nerds. Well, at that point I was a young nerd. Now I'm an old nerd. So at that point I was inside Columbia University in New York, designing the protocol with British Telecom, Columbia, and a few other guys. And then 25 years, I was really proud to see that the colleagues were able to build this IMS on top of the LTE. That was a great achievement. But let me introduce best now the 5G. So why we believe that 5G is disruption? The first thing is that mobile networks, as we know them, is mainly for consumer data. Basically, from the mobile to download huge video streams, social networks, and so on. But now what we see is that the 5G networks are moving beyond that. They are mainly targeting industry. They are targeting machine communications. And one of the problems that the mobile networks are facing is that they are not scaled properly for handle huge amount of data. I mean, the thing is that if we connect billions of sensors, we don't know when all those billions will be sending a huge amount of data. So in that sense, it's difficult to dimension the network. Then the other thing is that the industrial networks, the traffic requirements are totally different from consumer data. I mean, if you download a YouTube stream or some video, it doesn't matter if your collection is paused for a few seconds. But if you have, let's say, a forklift, which is coming 50 kilometers per hour, and that's controlled remotely, and it's coming against you, 1 second matters. I mean, you need to stop that. So in that sense, the requirements of the traffic in industrial networks is much more challenging. It requires reliability, it requires robustness. So that's one of the things that the public networks we need to address. So to give you an example of the impact of this kind of requirements. So this is based on some reports, so where basically the most of the wireless connectivity is based on Wi-Fi. There are different cases, Wi-Fi 5, Wi-Fi 6, but you can see that if the Wi-Fi is down for 1 hour, the cost might be around 30,000 euros. It changes depending on the industry, but it's costly. I mean, that's something that you cannot afford if you build this kind of wireless communications for industry. So that's one of the main reasons why 5G is going to be disrupting, because it's going to be providing this kind of reliability, robustness that the Wi-Fi cannot deliver in terms of this kind of communication, machine-type communications. Another scenario, just now to link with the previous talk, is that blockchain. We need communications, right? So what happens if you are in a rural area, you are in some place where you don't have any type of connectivity except your mobile network? You need to have this kind of reliable connectivity to make your transaction. One concrete example we had this summer is music festivals. In the music festivals, normally they have been using Wi-Fi to connect all the vending machines. But then again, every now and then, because of the congestion of the Wi-Fi, too much people trying to use the Wi-Fi, it goes congested. The vending machines are the football, similar to the football case. They were not able to purchase all the tickets, all the goodies from those machines. So what we did this summer in Finland, in those music festivals in the skirts of the city, is build a private network. On top of a van, they put the antenna. Inside the van, they have our packet core, and they were able to deliver high reliable connectivity for this point of sales. So that means that all these ICT type of applications could be built on top of these high availability networks. So, and then there are more opportunities. There are multiple segments that will benefit from bringing the 5G in addition to Wi-Fi. I'm not saying that it should be a replacement. It should be complementing Wi-Fi. So basically the idea is that industrial 4.0, mining, construction, agriculture. We had another case now related to mining. So we are working with one company that is producing this big machinery, Sandvik, for drilling into the mines. And they are evaluating how to combine both Wi-Fi 6 and the 5G. Because in some scenarios in the mines they have kilometers and kilometers of tunnels. So laying down the Wi-Fi access point within the mine is really challenging, because you need to use like a several fiber or connection to each of the access points and so on. With the 5G and leaky lines, then you can cover a large area. Then in the construction, so we have been working with construction companies, and it's interesting to see that when they start building, the first thing they do is all these big cranes, and then they need some sort of connectivity, private connectivity, for sharing all the information about the blueprints and so on. So they also need this kind of things, and then building the Wi-Fi in this harsh environment is challenging. Similarly to, we have one case in a sort of a steel factory. So the thing is that building this kind of Wi-Fi in those environments is difficult because of the amount of the Wi-Fi's, the coverage that you can get with the Wi-Fi. Instead, building on top of the crane, building on top of certain buildings, this kind of base stations, then you can have a few kilometers coverage within one base station. And then you have the availability and robustness of this kind of network. So just to give an example of the main factors that provide this kind of reliability is frequency. It's also an inconvenient, because that's the main difference compared to Wi-Fi. Wi-Fi is, unlicensed frequency, and that's the problem with the sort of collision congestion. So everyone here can have its own Wi-Fi using the same frequency, and then the access points, they need to hop trying to find a free available channel. In the private networks, they have a licensed frequency, but the problem is that the government, they need to support this kind of allocated frequency, which is not easy, mainly because the mobile operators, they capture the frequency. They pay a huge amount of money for those frequencies. So for the government, reserve a small chunk of that frequency is probably not very profitable. But in the long term, this sort of chunk of frequency can promote the growth in those segments, can promote new business models, and then they can bring overall more benefit to the local economy. So with this frequency compared to the Wi-Fi, then we can control the security of the devices can access the network. We can control the quality of service. We can decide which devices might have very low latency. I mean, with 5G we are talking about few milliseconds latency. Or we can define how many devices will be or should be accessed to the system. So that brings the reliability and robustness that is needed in this kind of industrial networks. Then the other thing is that since 5G has been designed having in mind this kind of industrial usage in the standardizations, I have been a delegate in standardization for quite some time. So the idea is that in the standardization we define what kind of features are required in order to interconnect like physical devices with wireless devices. So to give you an idea, your mobile device normally is designed to connect somewhere else in the public internet to fetch data. But your device, your mobile device, in the previous Gs of the mobile networks, they were not designed to connect to a private network. They were not designed to connect to a local area network where you have machines as part of the fixed infrastructure. So in the 5G, in the 3GPP, the Standardization Forum for Mobile Networks, we have been designing what is called 5G LAN. 5G LAN means it's a new, we are creating a new interface between the mobile networks and the fixed networks. What does it mean in practice? You have one robot in your factory, and then from that robot, then you can connect to the mobile robot, because all of them, they are part of the same 5G group. So that means that for software developers, they can implement applications that they work both on the fixed devices and on the mobile devices. And they can discover each other through the IP addresses and create as part of this local area network that is connecting both fixed and these mobile devices. Then the other thing, which is quite challenging, is called time-sensitive network. Time-sensitive network is, it means those networks where the idea is that they are fully synchronized, meaning the devices connected in the wireless is fully synchronized to the level of microseconds with the device in the fixed network. Why is that? So basically, it means, like the example before, you want to control a machine that you need to control in a matter of milliseconds. You don't want to control it in a matter of minutes, because that might be a disaster, right? So if you have this kind of devices that their clocks, local clocks, are fully synchronized, then you can send commands to those machines from the fixed networks in order to interact, in order to control, in order to be able to perform certain activities. And this is challenging. I mean, even the 3GPP has defined those functionalities, these features. We have implemented that, but we are still far from reaching the required accuracy. So right now, the maximum we can get between clocks on the fixed network and the wireless networks are around 100, 120 microseconds, which is okay, but might not be enough for certain industrial cases. But anyway, it's the starting point That means that 5G will become like a trusted network for this kind of industrial cases where we need devices, fixed devices and mobile devices connected, fully synchronized one with another. No? Yeah, okay. Then the other thing is that, and that's the other feature that Wi-Fi brings, is simplicity. You put the access point, then your device gets connected to the Wi-Fi, gets the IP address, and that's it. I mean, the mobile networks, 5G networks in general, or any mobile networks, are really, really complex. Base stations, huge power, configuration, different quality of service, and so on. So one of the things that we need to include when defining the 5G network is simplicity. How we can then connect or put a 5G access point besides a Wi-Fi access point, and seamlessly we can connect all those devices. We can register the devices with the SIMs, with all the required security, and then automatically that device gets fully connected. So in that sense, we need to support multiple scenarios. So in that sense, 5G brings new kind of deployments. So the 5G could be completely separated, completely isolated. So inside the factory, you have your own network, which is a truly private network integrated into the factory. Or it could be like a sort of branch of the public operator. So it all depends what are the business models that they want to follow. Because the mobile operators, they can offer the industry what is called one slice. Meaning that the same infrastructure, radio infrastructure that they use for the consumer data, they can separate one slice of that infrastructure and then allocate it, this is the lower case, allocate it to the industry. Or then the operators or the integrators, then they can sell a full-fledged private network which is completely isolated. So in that sense, I would say 5G is shaking the existing business models for the mobile operators right now. So now we see 5G gives the floor for new challenges. So then we have a mobile operator, which will continue with the current consumer data, might continue or might bring the private networks as an offer to the industry partners or customers. But then there might be new entrants. There might be an industrial party that then might require this kind of support, or it can be a third party, like an integrator. The integrator gets the equipment from a big vendor or some other vendor, takes care of the integration and delivers that to the customer. So in that sense, there are new roles that are coming up with these private networks. So the role of the infrastructure, I mean the factory that is the one that is interested in having the infrastructure, they can have their own private network, which is delivered by the integrator. Or it could be like the owner can lease or rent that from the MNO. So then we have the spectrum owner, which is the one that is having all the sort of ownership of the frequency, and then they can offer that as a service. So in that sense, there are multiple roles that are coming up, and there's a huge opportunity in terms of new business models that have to be taken into account. That might bring like a set of growth, new opportunities, new companies that can build and operate this kind of private networks. And we are helping in that, as we're helping our colleagues in the NGN. So now they have private networks, they have voice over LTE, and then the next step is we are trying to help them to bring this voice over 5G, which then would be quite unique in Kosovo. And our role is mainly support them in building all the software that takes care of connecting those base stations and then connecting those devices. So in terms of base stations, the radio, we are flexible. We are fully compliant with the standards, which means that depending on the customer, they can decide, okay, I want a Nokia, Ericsson, well, probably not Huawei, but we don't care. It's up to the customer to decide what kind of radio they want. And then with that radio, then we connect to our software, and then they can have their own private network. And this is how easy it can be. I mean, the network has its own graphical interface where you can add subscribers. I mean, with the graphical interface, you say, okay, this is my phone number of the SIM, this is the key, because that's important. Security is one of the most important factors in this kind of networks. And then you can visualize where are your devices, where are your base stations in an easy-to-use graphical interface. It can be network which is deployed outside, or it can be a network which is deployed inside a factory. So you can see where exactly are the devices and whether they are connected or not. And then you can check what is the performance. So the point is that this kind of private networks needs to be as simple as a Wi-Fi network, but bringing the security reliability that Wi-Fi cannot bring today. So what is the unique value? Efficiency. So basically, if you compare Wi-Fi in terms of number of access points that you have to deploy, maintenance of those access points, the capacity, the security, we calculated you are saving in OPEX about 25%, depending, of course, on the coverage you want to have. Then 5G brings these new features, 5G LAN, TSN, which then brings a lot of efficiency in terms of capacity. And then the most important thing is that you may or you may not have internet access. You might want to have fully closed network. So we have some customers in Germany that when we tell them, okay, we need to connect to internet to get some software update, no way. I mean, the network is fully closed, it's fully secure, no internet access. If you want to do a software update, you come to our factory with the USB and you do the software update. Because that means that it's really, truly private network to guarantee security. And then with that, then we have low latency, reliability, and so on. So we see that there's a huge opportunity globally, so based on different segments, manufacturing and so on. So now is opportunity for the newcomers to tap into that possibility. So, but we are not stopping here. So we are working, nowadays, we are already working with 6G, believe it or not. So we are working now with new terahertz radio modems. Of course, this will take several years. Then the other thing is satellite networking. You know what? Are you familiar with the International Space Station? We are there. So we built private network in the ISS last year. So, and then we are working, bringing this kind of satellite as an alternative communication in this kind of rural areas, far areas where you may not have fiber. And the last thing is positioning and location. We need to know precisely where are the devices under the network. So, just to finish up, the point is that with the 5G, you are disrupting mobile networks. You will deliver these devices fully wireless connected. Thank you.